it will be an incredibly exciting future where we're a spacefaring civilization and there are people on every part of our solar system and eventually going to other star systems. I think this will happen. I'd say it's highly likely we do over 1 million tons a year to orbit with Starship and probably close to 10 million. 11,000 satellites in orbit. That's more than twice as many satellites as everyone else combined. And with the Starlink V3 and beyond, we'll go to 100,000 satellites. That's really quite remarkable. It's quite difficult to build the internet in space, rebuild the entire internet in space, all of the hardware, all of the software, and yet the team has done it.
Flight 14 is expected to send Starship into a stable orbit for the first time. And if it works, SpaceX will finally move past the basic challenge of reaching orbit and begin testing whether Starship can do the job repeatedly. That is where Flights 15 and 16 could become even more important than Flight 14. What happens when SpaceX stops proving that Starship can fly and starts proving that it can actually become useful? Now, Flight 15 could become the first serious follow-up mission by carrying more Starlink satellites and pushing the new vehicle closer to routine service. Flight 16 could then raise the stakes with reused hardware and the first real attempt to bring an orbital ship back to the tower. Together, these flights could show whether Starship is turning into the launch system Elon Musk has promised or remaining a spectacular test program. A clean orbital mission would allow SpaceX to move forward quickly. Any major problem would force the next vehicle to repeat part of the test before the company adds something harder. SpaceX needs several strong flights in a row before it can trust Starship with expensive payloads and more aggressive recovery attempts. Now, Flight 15 may therefore look familiar at first, even if its purpose has changed. The most obvious job for Flight 15 is carrying a larger group of Starlink V3 satellites. Flight 13 released 20 of the new satellites during a short test mission, while Flight 14 is expected to place useful payloads into a stable orbit. SpaceX ultimately expects Starship to carry as many as 60 Starlink V3 satellites on one launch. Flight 15 could begin closing the gap between an early demonstration and the full cargo load the rocket was built to handle. That payload would make Flight 15 valuable even without a new record or dramatic stunt. Every satellite placed into the correct orbit adds capacity to the Starlink network. SpaceX can begin earning money from that hardware after the satellites reach their orbiting positions and enter service. Now, a successful launch would therefore produce a business result alongside the engineering data, making money for SpaceX. Starship must release the satellites close to the orbit SpaceX selected for them. A precise deployment allows the group to spread out sooner and preserves more of each satellite's useful life. And there also may be a change to the way the Starship releases its payload. 20 satellites already create a complicated sequence because each spacecraft needs room to leave without hitting the ship or the satellite ahead of it. A larger batch extends that sequence and changes the balance of Starship as the payload bay empties. Flight 15 could show the deployment system operating much closer to the pace required for regular Starlink missions in the future. And the booster may provide the most dramatic moment of Flight 15. SpaceX has caught earlier Super Heavy boosters with the launch tower, but the version 3 booster has not completed that same return. Recent flights have shown that getting the booster back through the atmosphere is only part of the challenge. The engineers still need to read light at the correct moment and slow the vehicle before it reaches the tower. And SpaceX will decide whether to attempt the catch while the booster is already heading back toward Texas. If the vehicle looks healthy and remains on target, controllers can allow it to continue toward the tower. Any serious problems would send it toward a safer landing point in the Gulf. And the ability to abandon the catch protects Starbase when the flight data does not support that risk. A successful version 3 booster catch would give Flight 15 a clear place in Starship history. It would also hand SpaceX a piece of hardware that engineers can inspect after a complete mission. The company would learn how the new engines handled flight and whether the booster structure returned in good condition. That information would set up the most important possibility for Flight 16. SpaceX could place the same booster back beneath a new ship, and the company has already reflown an earlier version of Super Heavy, so the basic idea has been demonstrated. Flying a version 3 booster again would carry more weight because this is the design that SpaceX wants to operate at scale. When they have thousands of ships in space, this is the one. And the mission would show whether the newer vehicle can survive a complete flight without requiring an extensive rebuild. The time between those flights would tell us almost as much as the reflight itself. SpaceX can always take a recovered booster and spend months rebuilding it. That approach may save the vehicle, but it does not create the rapid reuse that Elon Musk has described. Flight 16 becomes more meaningful if the booster returns to the pad after a focused inspection and only limited repairs. Once that booster launches for the second time, SpaceX gets an answer that cannot come from a ground test. The tanks must survive another full loading cycle, and the engines must fire again under real flight conditions. The booster then has to separate cleanly and return toward Starbase. A second catch would show that recovery still works when the hardware is no longer new. Flight 16 may also arrive at the right time for the first ship catch. Musk recently moved that attempt back by a few months and placed that first ship reflight near the end of the year or early next year. Now that schedule makes Flight 15 and 16 natural candidates for the catch, even though SpaceX has not assigned it to either mission right now. Flight 15 could provide another landing rehearsal before Flight 16 finally heads for the tower. SpaceX would receive the ship without soaking it in salt water or damaging it during an ocean recovery. Engineers could inspect the heat shield exactly as it looked after entry. They could then decide whether the ship needs major repairs or only routine work before another flight. Recovering both stages on the same mission creates a new challenge for Starbase, though. Super Heavy returns only a few minutes after launch, while the ship may remain in orbit much longer. The ground team must secure the booster and move it away before the ship approaches. The tower then needs to be ready to perform a second catch on the same mission. That may become one of the most important tests on Flight 16. Starship cannot fly often if every recovery occupies the tower for hours. SpaceX needs a smooth process for moving the booster and resetting the arms. A delay on the ground could force the ship to remain in orbit or abandon the catch entirely. Flight 16 will need another ship prepared while Flight 15 is still flying or being inspected. SpaceX must check the launch site and make sure the next countdown can proceed without lengthy repairs. And the gap between the two flights will show whether Starbase is becoming a working spaceport instead of a place built around one test at a time. SpaceX could still place a refueling experiment near this part of the schedule. NASA needs 2 Starships to be in orbit and move propellant between them before the lunar version can complete its mission. That test remains one of the largest challenges ahead. SpaceX may choose to prove reliable launches and recovery first, so the refueling mission does not depend on several unfinished systems at once. That is why Flights 15 and 16 do not need to attempt everything. Flight 15 can concentrate on delivering a useful payload and recovering the new booster. Flight 16 can take that booster back to space and make the ship catch the main event. Now, if you enjoy Starship coverage that explains what SpaceX is trying to achieve without burying the answer under jargon, please subscribe to this channel. Now, Flight 14 may deliver the historic first orbit, but the 2 missions after it are very important. They could tell us whether that success can be repeated. That's the difference between just a test program and the beginning of an actual launch service for NASA and other purveyors. Flight 15 can prove that Starship can carry valuable payloads and bring its version 3 booster home. Flight 16 could fly that booster again and attempt the first orbital ship catch. If SpaceX completes that sequence, Starship will begin looking less like a prototype and more like the reusable rocket Elon Musk has promised for decades.